Back at it. Chem 110A, Chapter 8. This is percent composition by mass for compounds. Pages 123 through 126, exercise 8A. Basically what we're talking about here is trying to look at every compound, not just terms of how many moles are in each of each element in a compound, but also the amount of mass that each one of these elements contributes. So we have to consider both how many and how heavy. How many has to do with the moles, how heavy has to do with the mass. Okay, so let's think about HBr. HBr is your basic diatomic element, one hydrogen and one bromine. So if we had 1 mole of HBr, you would agree that there's 50% H and 50% Br in every 1 mole. 1 mole of H and 1 mole of Br. But we also know more about each of these. If you look at the periodic table and you look at the molar mass of hydrogen, there it is. 1 mole is the same as 1.008 grams. And if you look at the molar mass of bromine, 1 mole is 79.904 grams. In other words, if we weren't going to look at number of each, but how heavy each, 1 mole is the same as 1 gram for hydrogen. 1 mole is the same as 80 grams for bromine. So the bromine is heavier than the hydrogen by an 80-to-1 ratio. Okay? So if we were sort of able to look at a picture in terms of mass of HBr, there would be the hydrogen, and there would be the bromine. So obviously the bromine is way heavier than the hydrogen. So how do we go about doing that calculation? Well, it's the way we always do percent. It's right there. Part over whole times 100% is equal to the percentage of the part. So here's the problem for you to try. What are the mass percentages of the elements in aluminum nitrate, AlNO3,3? Report the answer to the nearest 0.1% or to the 10th place. So hit pause, give it a go, come on back, and then we'll see how you did. Welcome back. Okay, so there's part over whole times 100% gives us the percentage of the part. So this is how we would calculate the whole. You know how to do that. 1 aluminum, 3 nitrogens, and 9 oxygens is in aluminum nitrate. 1 aluminum weighs 26.98 grams per mole. 3 nitrogens, each is 14.01 grams per mole. These are off the periodic table. And 9 oxygens, as you remember, is 16 grams per mole. You add all of that up, and 213.01 grams per mole is the whole. This total is the contribution that aluminum makes to the whole. 3 times 1401 is the contribution that nitrogen makes towards the whole, and 9 times 16 is the contribution that the oxygen makes to the whole. These are the parts for aluminum, nitrogen, and oxygen. So the way you go through the rest of the problem is pretty simple. See if I can get us all up on the, there it is. Percentage of aluminum is the part that's aluminum, 1 times 26.98 divided by the whole, 213.01 times 100%. To the nearest 10th place, it's 12.7% aluminum. Percent nitrogen, 3 nitrogens, 3 nitrates, 1 nitrogen per every nitrate, 3 nitrogens, times its molar mass, divided by the total, times 100, gives us 19.7% nitrogen. And then there's 9 times 16, because there's a total of 9 oxygens, divided by 213 times 100%. It's mostly oxygen. If you've done all this right and you add these all up, you get a total of 100%, which it does. These are the percentages of each of the elements in this molecule. If you need more practice, and I know you do, exercise 8A will get it done for you. Good luck.